How we doing, guys? So in this video I'm going to show you how to find the center of a circle using two chords, and then we're going to go on to explain the construction in relation to an external tangent and then creating an internal tangent. So first things first, we're going to go ahead and find the center of this circle. So anything in red is construction, anything in black then is going to be in heavy. So if we're given in a typical junior cert question in short questions, or even so mostly in the short questions, you might be given a circle or a circle within some sort of object, and you'll be told to find the center, showing all constructions or whatever. So the best way to do this is simply to construct two random chords. Okay, so a chord does not continue on. It's basically just like a little section of a circle. It's basically one line which contains 2 points on a circle. So there's one chord, and I'm just going to construct another one over here. Okay, so there's two random chords. Next thing, we're going to grab our compass. Okay, so what we're going to do is bisect both of these chords, and the bisector of those chords will meet in the center. Okay, so we're going to go ahead and bisect. So as always, just pretend it's a normal line, forget that it's within a circle for a second, and just bisect that line. So you want to extend your compass greater than halfway, describe an arc either side of the line. Okay, you're going to come back and go to the other side, keeping the same distance on your compass, and just scribe an arc one side of the line and on the other side of the line again. Okay, and those two sets of arcs will intersect. Where they intersect, you basically want to join the dots. Okay, and just extend on that bisector as well. Okay, so that's the first chord done. Now we're going to go ahead and bisect the second one. So again, compass greater than halfway, scribe an arc either side of the line. Same distance on my compass going from the other side, scribe an arc, and where those arcs intersect, you want to bisect, or you want to draw your bisector. And there you have it. Where those two lines meet is the center of the circle. Just there. Okay, so you got to bisect two chords, and those bisectors would intersect in the center. There is no need to do 3 or 4 chords. There is no need. It's a waste of time. Alright, 2 is all you need. Okay, moving on. So, an external tangent. Okay, so we are given the center points here. I'm just going to highlight them for you guys. Right, so there's the centers. Okay, so for an external tangent, so I'm going to label these actually A and B as well, just to help when I'm speaking about them. Alright, so we're going to construct an external tangent. Firstly, let's try visualize what an external tangent will look like. Okay, so if I was to use my pencil as the tangent, there we are there. So an external tangent means it's basically on the outside of the two circles. It's not like, for instance, with the internal tangent down here, it's not going between the two circles. Okay, so our external tangent is on the outside of our two circles. So first thing we got to do is join the center points. Alright, that's nearly a good habit to get into. Majority of constructions are just simply join the two center points firstly. Right, now if you cannot remember whether I'm adding the radius of the smaller circle or subtracting it, the way I like to remember it is EX, or even just the X. Okay, so for those of us doing graphics and we're also doing MTW, or you might be doing some sort of engineering, when we mark, what do we mark our waist with? x's. Okay, so what we're trying to do then is take away our waste, take away our x's, get rid of them. So we're going to subtract the radius b from a. Okay, so if you can try and remember it like that, x, we mark our waste with x with MTW and engineering. So we're going to take b away from a. So you want to take the radius of b and subtract it from a. Okay, now we're going to draw a new circle within a using that mark we just found by subtracting radius b. Okay, so that's our new important circle that we've just found there within b. Okay, so I'll just show you this distance here, RB, and there it is there. That's distance RB, radius b. Okay, next thing, we're going to bisect the joining of the two centers, and we're just going to draw a semicircle. So extending our compass greater than halfway, scribing our arc above the line, below the line, and doing the same on the other side. Above the line, below the line, and we're just joining them. Alright, so that's why bisecting a line was such a important construction when we were doing it earlier in the year. There you go, there's the center, and just using that center that we've just found, extend out to A or B. Alright, so it should be the same. Yeah, perfect. And we just want to draw a semicircle. Okay, so that's our semicircle drawn. Now, a very important point is right here. Okay, so where our semicircle has just intersected this new construction circle that we've drawn by subtracting that radius b, you want to go from A, center of A, sorry, through that point we found. Okay, so nice and light construction, sharp pencil. You want to go all the way out until you hit the outside of the larger circle, or the original circle we have. Okay, so that is a point on the tangent. Now, to find the other point within circle B, we're going to use sliding set squares. So we're going to construct a line which is parallel to this line we've just drawn. So set up one set square so it's parallel, train tracks. So here's my train tracks, and I have my anchor down below. And I'm just going to slide the whole way along till I'm at the smaller circle there, B. And I'm just going to follow out like so. So that line there and that line there are parallel. Now, the important point for all this was where the semicircle intersected this new smaller circle we found. So that point there was very, very important for this construction. Extremely important. And what we're after finding is 2 points of our tangent and our 2 points of contact. So you can just go ahead and draw your external tangent like so. So there's our tangent. And if you're wondering where's our points of contact, right there. So POC for point of contact, POC for point of contact. Okay, very good. So that's our external tangent. So the important thing to remember there is when we're dealing with external x waste, you're subtracting the smaller radius from the larger circle, drawing our small circle within it then, and then our semicircle to finish it off and locate this extremely important point there. Okay, our internal tangent. So I'm just going to show you again what an internal tangent looks like. So we want our tangent to sit and squeeze basically in between those two circles. Okay, so that's where we want our tangent basically to end up. Okay, so we're going to go ahead and do that. So as always, we're going to join the two center points. So join our two center points, nice and light construction. I'm just going to label these again for you just for when I'm talking through it. It might be easier to understand. Okay. So with the internal tangent, it's a little bit different. We're not taking away, we're actually increasing. Okay, we're actually increasing the size of this circle A. How do you remember that? IN, increase. Okay, so we're going to take the radius B again, or it's a smaller circle, and you're going to add it on to the radius of circle A, and you're basically go ahead and draw that circle, that new circle, which contains both radius A and radius B. Okay, so there you have it. Now we're going to go ahead and we're going to find the center of this line AB. So as always, greater than halfway, scribe an arc above the line and below the line. Do the same on the other side, keeping the same distance on my compass. You want to join those 2 points, find the center of that line AB. So there's the center, and I'm going to go ahead and draw my semicircle. Okay, so there's my semicircle drawn. Now, so our important point in our external tangent was where the semicircle met that new construction circle we made. It's the exact same situation here. Where this semicircle meets this new circle, the bigger circle that we've drawn, which contains radius B and radius A, so there's that radius B I added on. So there's our important point there, where the semicircle intersects that new circle. What you want to do there is exactly, well, it's kind of similar to what we did up here. We're joining back to the center of A, which is the larger circle. So join that back to the center, and where you intersect the original circle A, that is your point of contact. Alright, so that's one of our points of contact. So our tangent is going to be hitting that. So that's one of our points of contact. You want to do similarly to what we did up here with sliding set squares and the parallel lines. You want to bring that line again parallel using train tracks, sliding set squares from the center B out, and where it intersects the outside of the circle, that is a point of contact. You can go ahead and draw your tangent then. So you see how it fits in perfectly just within both of the circles. Go ahead and draw your tangent like that. And I'm just going to write tangent down here. And once again, POC for point of contact and POC for point of contact. So I'll just talk through that just briefly. So our internal tangent, we're increasing the size of our larger circle, taking the smaller radius and adding it on. So there's our RB. You're adding that on, you're increasing it. Drawing our semicircle after we bisect the line AB, which contains both the center points. When we've drawn our semicircle, you want to find your point of contact, so bear with me. So as I was saying, where that semicircle intersects the new larger circle we've drawn by using the radius B and adding it on to circle A, that's our important point here. You join that back to our center A, where that intersects our circle A, that's our point of contact. Okay, and similarly down here, we're just going parallel. So that's parallel, that's your train tracks, and that helps us find our point of contact on our smaller circle. Yeah, if you just look at the similarities between the internal tangent and the external tangent up here, where the semicircle in both cases intersects the new circle that we've drawn by either subtracting the radius or increasing the radius. So I'll just point out those points. So we have here and here. Both of those points go back to the center of the larger circle and also help us find our point of contact, whether it be going from through that important point we're talking about, extending it on, or for instance here we have our important point and it's on the outside of the circle. When we bring it back to the center, it locates the point of contact for us there. Okay, so that's the external tangent and the internal tangent, and also finding the center of the circle using chords. Okay, so thanks for watching.